Hello everybody, it's Mrs. Pound and I am back with your last video for Chapter 3.2 on Chemical Reactions from Purposeful Design's Physical Science. The topic of today's video will be Section 324 on Types of Reactions, and we have covered a lot in this chapter. We have covered products and reactants, we have covered rates of reaction, we have covered chemical equations, and we've learned how to balance equations, and we've talked about the energy involved in chemical reactions. So we have covered a lot of information. Our objectives for today's video are to classify chemical reactions and determine whether reactions will occur according to the metal activity series. So our first type of reaction is a synthesis reaction. This is when two or more substances combine to form a product. It's also known as a combination reaction. So the general form for this type of reaction is A plus B yields AB. So we can see here in this reaction we have 2 units of magnesium reacting with oxygen gas to yield 2 units of magnesium oxide. So we took 2 things and we combined them into one. That's what makes this a synthesis reaction. So synthesis always means making or building, and we make or build one thing. The opposite of a synthesis reaction is a decomposition reaction. This is when a substance is broken down into 2 or more products. So here we have AB yields A plus B. So we have, this is actually carbonic acid. It's aqueous, it's in water, so that's how I know it's an acid. Yields H2O, so water plus carbon dioxide. It is breaking down. And so that is why that is a decomposition reaction. When something decomposes in nature, it breaks down. So that might help you remember that. Combustion reactions are a reaction that occurs when a substance reacts with oxygen. So here we have methane gas, CH4 plus 2O2 oxygen. So that presence of oxygen here yields CO2 plus 2 units of H2O, water. So here, presence of oxygen, combustion, think burning of things, okay? So this is the burning of methane, and when we have combustion occurring, it also produces carbon dioxide and water. A double replacement reaction. This is AB plus CD yields CB plus AD. So I like to think of this as you're at a dance and there are 2 couples dancing, and then they switch partners and dance with a different partner. Okay, the 2 couples switch. So down here we have silver nitrate reacting with sodium chloride, and the silver combines with the chlorine and the sodium with the nitrate. So here we switched AgCl, NaNO3. So the outside ones combined, the inside ones combined. They switched partners like at a dance. There can also be a single replacement reaction. This is where we have something like A plus BC yields AC plus B. This is where you're at a dance and there's a couple dancing and somebody cuts in and steals the other partner. So we have here magnesium metal plus copper 2 sulfate yields copper metal plus magnesium sulfate. So magnesium stole the sulfate from copper, stole their dancing partner. Okay, so they are just switching. Now, single replacement reactions proceed to completion when the element that is replacing another element in a compound is more active. And you might ask, how do I know whether it's more active or not? Well, we use something called the metal activity series to determine if the reaction will occur. this is a list of metals. The more active metals are at the top and the least active metals are at the bottom. So if a metal is higher in the activity series than another metal, it will steal the other one's partner. So, for instance, we have silver plus aluminum chloride. Will they react? Would be the question. And the answer is no, because silver is less active than aluminum. So we look over here, and aluminum is right here in my activity series. Silver is down here. Silver is less active, so silver's kind of shy, not very pushy. It's not going to go over and ask to take aluminum's partner at the dance. However, with potassium and zinc chloride, if we look at potassium, potassium is up here. It is more active than zinc. So potassium's kind of pushy. It's more active. It's going to go in there and cut in on zinc and take their partner at the dance. So yes, potassium is more active than zinc. Now, what is happening is when potassium and zinc chloride are placed in solution, the zinc chloride will separate into a positive zinc ion and a negative chloride ion. Potassium will bond with a negative chloride ion to produce potassium chloride, and a solid zinc precipitate will be produced. Remember when we were talking about evidence of chemical reactions, a precipitate forming? So in this case, yes, a zinc precipitate is being formed. So we have the reaction 2 potassium plus zinc chloride yields 2 potassium chloride plus zinc, because potassium is more active and will cut in and steal the chloride from the zinc, in a sense. Okay, so our objectives for the video were to classify chemical reactions and determine whether reactions will occur according to the metal activity series. Now, don't forget your 5 questions in the margins. Also, keep watching this video to answer the 5 questions at the end. And this is the last video for this chapter, so you have a test that you should start studying for.